So we have a bottom of a hill, a car has an initial velocity of 16 meters per second. So let's say we've got a V0 equals 16 meters per second. There's our car. The car is uniformly accelerated. The acceleration is minus 2.2 meters per second as it moves up the hill. So what that means is if the velocity is in this direction, the negative is the acceleration, it's going to be slowing down. All right, and we see for 5 seconds. So let's see then. After 1 second, it'll be 13.8. Another second, it will be 11.6. Another second, it will be 9.4. Another second, it will be 7.6. So this is 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. It would be traveling 5.4 meters per second. How far does it travel during this 5-second interval? Well, we can say that the average velocity is always the total distance over the total time. So the total distance would be the average velocity times the change in time. Well, we know the time is 5 seconds. The question is, what's the average velocity? The other formula we have for average velocity is v plus v0 over 2. So the final velocity we see is 5.4. Initial is 16 all over 2, which gives us 21.4 over 2, which works out to be 10.7. 10.7 times 5 is 53.5. Looks like the closest one is this one. Let's try another method to do this. Let's use our average velocity table. Because remember, our first approach in solving a problem is always to try average velocity, which we did. Second is to use the average velocity table. So we have time, 0, 1, 2, 3, 4, 5. We have a velocity of 16. Minus 2 is 14. Minus another 2 is 13.8. Minus 2 is 11.8. Minus another 0.2 is 11.6. Minus 2 is 9.6. Minus another 0.2 is 9.4. Minus 2.2. Minus 2 is 7.4. Minus another 0.2 is 7.2. And number 5 would be 2. That would be 5 meters per second. So we can see we made a quick mistake here in our math. And then our average velocity, which we only need for the entire thing, is going to be 16 plus 5 is 21, divided by 2 is 10.5. And then if we have 10.5 times 5, 5 and 2, and 52.5. So it is 52.5. We could use a third technique to do this. We could say V equals AT plus V0. And let's see, the acceleration is minus 2.2. The time is 5, and the initial velocity is 16. So we can find the average velocity to be minus 11 plus 16. And that instantaneous velocity then is 5 meters per second, which we got in our table in our other methods. And so then we could go back to using the average velocity, which is V plus V0 over 2. And that is 16 plus 5 over 2, 10.5 meters per second, which will get us the same 52.5. We could do it yet again another way. And just start out with our position formula. X equals 1/2 AT squared plus V0t plus XO. Well, the acceleration is minus 2.2. The time is 5. Initial velocity is 16. 16, and the time is 5. The initial position is 0. We set that equal to 0. So we're left with minus 1.5 times 25 plus 80. And 25 times a minus 1.5 It's 37.5, so minus 37.5 plus 80 That's 1.1, made a mistake. It's minus 1.1 times 25 plus 80, and 25 times 1.1 is 5,25257 is minus 27.5 plus 80 is 52.5. So we can see there are a lot of ways to do this question.